Alright, so here we go. Let's get our notes out and let's get started. I picked out a few Alright, so we're all focusing in. We talked about the cereal drive that starts next Monday. 2 boxes, 2 points. Yep.
Cereal. 5 boxes, 5 points.
Get Dollar General cereal.
No, you.
If you eat it, if that's what you eat in your family, that's absolutely fine.
I gives you cancer. Like the red dog.
I don't know. Honestly, if I knew what baby cancer was there. Alright, here we go. Number 38. I am pulling a couple problems out of your book. I have no idea if we've already done these or not. We're going to do them again if we have. This is page 461. I am just picking random craft problems. Now, obviously, some of these are harder than others. I am not going to choose a really, really hard problem for your quiz, but I'm not going to pick one that's super duper simple either. So let's see what this is in terms of hardness. Let's see if this is a hard one or an easy one. I feel like I'm missing some people. Oh, here comes Annie with a pass. Thank goodness. Thank you, Annie. Emily, I knew would be gone. Is Clark still gone? Thank you, Annie. You signed that, sweetie.
What?
Who's this from? Clara is here, as is Mallory. Who else sits in the back row besides Mallory? Michaela. And, okie dokie. All right, so what's your thought, Michael? Get your head up. You should already have this guy done. What's your thought on this? We're changing one side into the other. Now, it makes zero difference which side you start on, and the steps are going to be exactly the same. Personally, I don't like secants, so I would probably change secant into 1 over cosine on the top and the bottom. Could you do that over here and change the cosine into 1 over secant? Absolutely. Either way you go, either one you do, you're going to end up with this big ugly mess. This is a big fraction that has 4 little pieces in it. What is the common denominator of the 4 little pieces? Cosine. So I'm going to multiply each of the pieces by cosine. And the reason for doing that is right there. Right? So I have 1 plus cosine over 1 minus cosine, which is exactly what we wanted. So I would say that's a super duper simple one. Let's see.
That's super simple.
If 39 is any more challenging.
39 is a hard one.
Is it?
Yes, it is. Miss Ford, that was not easy.
It's a big one, so I'm going to have to raise
What
this.
number was that one?
I would say
This was 38, now I'm doing 39. All right, I'm going to erase this one now. Anybody have a question about what I did?
What? You just multiply cosine x.
Multiply everything by the common denominator.
Is this all 5.2?
Yes.
Yeah.
Okay,
All right, so now I'm going to try 39, which is a bigger problem, at least initially. I don't know if it's going to be any harder, but let's see. So we have sine t, 1 minus cosine, plus 1 plus cosine over sine. equals 2, 1 plus cosine over sine. Okay.
Let's do the left side.
Yeah, definitely. I think we'll do over here. And if nothing else, we can always get a common denominator and add our two
That's right.
fractions. Now, what we can't do is change 1 minus cosine into sine. Remember, 1 minus cosine squared is sine squared. Those manipulations with the ones, 1 minus or 1 plus or whatever, come from the Pythagorean identities squared. Everything's going to be squared before you use those. So I would just get a common denominator here. So this one
So it's times sine.
would need to be times by sine. And this one would need to be times by 1 minus cosine. Now, both fractions have the same denominator, right? So we can add them together. So the denominator is sine 1 minus cosine. And then our numerator. Here we're going to have just,
Can you change that into 1 minus?
I might, but I'm not going to do it just yet. I have sine squared right now. And then what do I have over here?
1 minus.
I'm going to FOIL. That's a FOIL. So I have 1 minus cosine plus cosine minus cosine squared.
But the cosines cancel.
These cancel, yep. Alright, so what have I got? The sine minus cosine squared, I don't think is anything that we know yet. It actually is something, it's a 5-4 identity that we haven't done yet.
1 minus cosine squared.
Oh, 1 minus cosine squared? Putting the 1 minus cosine squared together, what's that? That's sine squared. So these two make sine squared, but I already have a sine squared. So that's going to be 2 sine squared? Oops, not x.
Now, why would you do that?
Well, that's a great question. Because, why do you ask that question? Why would I do that?
Because you have cosine on the top.
Bingo. Now, here's a perfect example of where I can do something, but it doesn't make sense. Because what's going to happen to this sign right here? If I make this move, which is completely legitimate, this is correct, what's going to happen here? I'm going to cancel out the signs, and why is that bad? I want 1 in the denominator. So I think you're right. This might be something I don't want to do, even though I can. I might not want to do that. Let's come back up here. All right, so think about what you said, Brenton. You said, why would you change that when you want cosines? So what's this?
1 minus cosine.
So maybe that's the way I need to go. 1 minus cosine squared plus 1 minus cosine squared over sine 1 minus cosine. All right, so what we did was change this into 1 minus cosine squared, because that's what it is. There was already a 1 and a minus cosine squared already up there, so that's why I have all that.
Can you combine like terms?
You can combine like terms. So we have 2 minus 2 cosine squared.
And you can take 2.
And Brenton says, all right, things are looking okay, but I gotta get rid of this square deal here. There's no squares in this. So he says, I better factor. Maybe I can cancel. So we'll take a 2 out. Still can't cancel. Don't try to cancel, you can't. But what can you do? Factor what?
1 minus cosine.
Exactly. 1 minus cosine squared factors. Erase my stuff I crossed out. So that would be 2 times 1 minus cosine, 1 plus cosine?
Yes.
Okay. So we went from here up to here, and now I'm coming back over here. And that's sine 1 minus cosine. All right, is that good news? Are things starting to come together here?
Yes.
That's going to cancel, and what am I going to be left with? The answer, what I want. Now, I love the fact that Brenton and maybe some others of you were thinking, wait a minute, that's really not what I want to do because this is my goal. So I did what took me to my goal. Got cosines in the top and left my sines in the bottom. That was my goal. All right, one more. Let's do one more, and let's see. This one is not in the exercises. This one is another one I found. All right, any questions about this before I erase? All right, so here we go. Here we go. Here's what we're trying to prove. It isn't a number. Anybody have a thought on how we might start? Okay, so over here we could get a common denominator, so that's one option. Are there any other options over here that you could do?
Well. Yeah. We'll seek it -1.
Be careful, it's not squared.
It's not squared, never
So
mind.
it's not a Pythagorean identity. However, it is a secant. I personally don't care for
It's
secants.
gonna be 1, right?
No. So I'm gonna rewrite this. Now, some of you are gonna say, oh, Mrs. Ford, I'm not sure why you're doing that. Trust me, I think it's probably the best thing, the easiest thing to do. We could get a common denominator and add. Well, let's go ahead. Let's get a common denominator and add. I think it'll be okay. There are only ones up and top, so that really helps. So let's go ahead. Our common denominator, because that's what's going to occur to you to do. That's what you're going to think when you look at this problem. So what is our common denominator? Secant +1 and secant -1. What's our numerator now when I put these together? These are only being times by 1. So it's going to be secant +1 plus secant -1. Right?
That would be 2 secant.
Which would be 2 secant. And what would the bottom be? Let's go ahead and multiply that out because nothing's going to cancel, so we might as well FOIL it. What's that going to be?
Secant squared.
-1? Wait, now it's squared. So let's go back to our Pythagorean identities. Is there anything that I can do? Sometimes the answer is yes, sometimes the answer is no. Is there anything I can do with secant squared -1? This is what I have memorized.
Yeah, it's gonna be tangent squared.
It would be tangent squared. So now I have 2 secant over tangent squared. What do you think? What? Okay, so this is, Katie is saying, this is a tangent in the denominator. Now, what do we know about tangent and cotangent? They're reciprocals. So if you have a tangent in the denominator, that's the same as having a cotangent in the numerator. So we can, now just chill out, I like her thought. I like her thought. And the reason I like her thought is she's paying attention. Now, Katie, you got too many of them up there, but now you were getting close. Would you agree? We're getting close. I want to keep the 2, and I want to keep one of the cotangents. So what do I have left? I'm going to put those parentheses in. I shouldn't do that. I'm not factoring. I'm going to split this apart. I've got my 2, and I've got 1 cotangent. Now, what's this? 1 over cosine. And what's the other cotangent? Well, what is it in terms of the quotient functions? Cotangent. Cosine over sine. So we kept the 2, and we kept 1 of the cotangents. Then we took the stuff we didn't want. There's no secant up here. So I changed it into 1 over cosine. And the other cotangent I changed into cosine over sine. So I kept the part I wanted. It's all times. So I split it up however I want. I kept the part I wanted and changed the part I didn't. The cosines are going to cancel. So I'm going to be left with 2 cotangent times 1 over sine. What's 1 over sine? Cosecant. And that's what we were after. So I think one thing that came out of today's practice is keep your eye on the prize. Pay attention to where you're going. And that will help guide you. Because now you've practiced enough, you're starting to see multiple options. I could do this, or I could do this. Keep an eye on where you're headed. Okay? Monday, we'll see how you do. Right now, though, we're going to finish up 5-3, hopefully. I'll keep an eye on the time, too, because I think you're supposed to have lunch this period. I prefer that we just skip it. But
Your class have one.
all right, so what did we talk about yesterday in terms of 5-3? Do you remember? Let's do a couple quick review problems. We talked about the sum and difference identities, and the tangent one is the hardest, so we'll practice another tangent one, but it's only hard because of the arithmetic. It's not hard in the process. So let's look at the tangent of 165. Not 5-3? Oh, this is not a book problem. No, this is an example. All right, we're taking notes now. We're learning how to do this. Actually, we did this yesterday. We're just reviewing. We break that up into 2 of our special angles, remember? But when Mrs. Ford says special angles, she doesn't mean just 30, 60, and 45. We talked about that yesterday, right? It means a 30, 60, or 45 in any quadrant. Okay? Now, I'll give you a little hint. Take it or leave it. Whenever I have a 5, I think 45. So I'm going to immediately think 120 and 45. Now, before you say, can you use 120? Think about it. Think about it. What does 120 look like? It's a 60-degree reference angle, right? So I can use it. That's a root 3, that's a 1, that's a 2, and that 1 is negative. Be careful. That 1 is negative. 45, of course, I use all the time. There we go. So now we're looking at our green sheet down at the bottom where it has the sum and difference, because this is a sum. This is the tangent of the sum. right? We talked about these yesterday, right? Some of you are looking at me like you're clueless. This is your U and V, and it's a plus. So again, those formulas are doubled up. Use the pluses on top, right? So use the top set of signs. So what's this going to be? Tan 120 plus tan 45 over 1 minus tan 120 tan 45. Look at the formula. If you are doing the plus part, use the top signs in the formula, and that's a plus and that's a minus, right? So what do we do now?
How you find the angle?
Well, I already did that. I kind of worked ahead. So now I just start plugging. So what's the tangent of 120? The tangent, negative root 3. I wouldn't put the over 1. It's just going to make a mess. So since it's 1, let's just put negative root 3. What's the tangent of 45? 1. And the same two numbers go on the bottom.
That'd be a 1 plus.
It would be. It would be. It's going to be a 1 minus a negative. I don't need these anymore, so I'll erase those. So now I've got negative root 3 plus 1 over 1 plus root 3. Do not embarrass yourself by canceling. You cannot cancel in an expression that has pluses and minuses. You cannot cancel unless you can factor. There's no factoring, therefore there is no canceling. So what do we have to do though? We gotta multiply the top and bottom
1 minus root 3?
by the conjugate of the bottom, right? The trigonometry ends right here. Everything else now is going to be arithmetic. Just cleaning it. So we'll FOIL
What's that 1?
first,
Minus 3.
outside, inside, last. First, outside, inside, last. Now, some of that you may be able to do in your head as you go, and that's fine. I wrote every single thing down. So what do we notice?
Well, the negative 3 and the negative root 3 and positive root 3 on the bottom cancel.
Indeed, that's why we do what we do, right? To get rid of that.
It's going to be -2.
Negative 2 on the bottom. All right, what's on the top?
Negative 2 root 3
Negative 2 root 3
plus 4.
plus 4.
Now, can you cancel the 2?
What do you think?
Yeah.
If you can factor it out, you can cancel it. Can you take a 2 out of that top?
Yes.
You sure can. And in fact, I'm going to ditch the negative right along with it. So I'm going to have a positive root 3 minus 2. And that is the answer to the question.
What a problem.
What a problem. Unfortunately, the tangents are always that way. All right, so we talked about that yesterday. We also talked about a problem like this, where it says simplify cosine 200 cosine 30 minus sine 200 sine 30.
Oh yeah, and you find the...
So this is the kind where you're supposed to, it's like reverse. The formula is given and you have to figure out which formula it is. So it's cosine cosine minus sine sine. What is that?
Cosine.
That's a cosine formula. Now figure out, okay, first of all it's cosine. Cosine, cosine, sine, sine is a cosine formula. If that's a minus, then this is a plus. So your U and V are being added. Well, now you look at the angles, your U and V are 230. So this is the cosine of 230. Everybody kind of remember talking about that yesterday? You like those? Good. now, I want to do a couple more problems for you. So let's do, I'll get these out of the book here. 5-3.
So we gonna start the homework?
These will be a couple problems from the homework. I'm not starting the homework for you, but I'm going to do a couple from your homework. We're going to prove another identity. You like that. You're going to prove that
What number?
this is number 29 on section 5-3. This is 29 on 5-3. Brenton says, well, it's one we got to do. I know, Brenton, that's why I picked it. I know. He's the nicest teacher in the world, I keep telling you. All right, here we go. The teacher that doesn't give you homework, right? All right, here we go. You're going to prove this identity. Now, first thing you might want to consider is changing that pi over 4 into 45. I hope we haven't forgotten. Pi is 180 divided by 4 is 45. Now you have a formula for this.
We do.
You do.
It's the co-function.
So no. You have a formula. That's not a 90, Brenton. This is not a co-function identity. You have a formula that tells you what to do when you want to take the tangent of two things added together. We just did it.
The unit B.
Yes. So this, we're taking the tangent of two things added together. So what's that going to be? According to the formula, tangent of the first plus tangent of the second over 1 minus tangent of the first, tangent of the second. The tangent of 45 can be evaluated. There's 45. What is the tangent of 45? 1. So now you have tangent plus 1 over 1 minus tangent times 1. What was I trying to end up with? That. We're done. That's all there is to it. You're done. You did it, Jack.
So, is that circle thing a number, or is it?
That's a theta. That's a variable. That's a theta.
So it's like the same as the X?
X. Yep, again, and I've told you before, and I'll tell you again, use whatever letter you want.
Oh, so you can change it?
You can change it. You can change it. Yeah, that's a theta. The letter theta. Is your hand up over there? No. All right, let's try another one. Let's try, how about 41? That one looks like it might be a challenge. Is that one assigned to Brenton?
Yes.
Oh, good. All right, so 41, here we go. The cosecant, I'm going to go ahead and make this 90 minus u equals secant u. Now, that is a cofunction identity, but it says prove it. It says prove it. Identities are theorems. They're proven. So now what you're going to do is actually prove this is true. I told you it was true by putting it on the worksheet. It's in your book. You had to memorize it. But now you're going to prove it. Okay? You're going to prove it's true. That's what mathematicians do. They just prove things. Now, here's my issue. This is like a u minus v problem. But in my list, I don't have a cosecant u minus v formula. Right? Can you think of a way out of this?
Are you going to do the reciprocal?
I could say, all right, that's the same as 1 over
90 minus
the sine of 90 minus u. Would you agree with that? Now, I do have a formula for this,
Yeah.
correct? So here we go. The formula, well, that is cosine, but I'm proving that set of formulas, so I'm not gonna use that. You are exactly right, Brenton, this is cosine. But again, I'm proving this, okay, not using it. All right, so here we go. Sine u minus v. What is that formula? Look on your sheet. Sine u minus v. Sine of the first, cosine of the second, minus cosine of the first, sine of the second. That is one of my formulas. Down at the bottom, it's one of my sum difference formulas. It just happens to be under 1 now, but it's down there. Now, tell me about 90.
Is it?
What do you know about 90? It's right here. And if we let the radius be 1, at this point, what would those coordinates be?
0, 1.
0, 1. So the radius is 1, x is 0, and y is 1. I need the sine. The sine will be y over r, which is 1. So this guy is just 1.
Yeah.
What about the cosine up there at that very same point? What's the cosine?
0.
That's 0.
So does that cancel out sine u?
What do you think? It's
Yeah.
multiplied.
Yes.
Yeah. So now we have 1 over. This is just going to be cosine u. And that is going to be 0.
What did the song guy consider?
You're multiplying by 0. Right? So 1 over cosine u, which we know is secant u. And that's what we were trying to prove. Now, unless you are told, as you are in this problem, prove this theorem, you can use that idea. So you know, in a regular problem, you can change this into secant automatically. It is true. You just proved why it's true. Don't you feel good about that?
Weird. Will ever happen where like you might be undefined?
Some really smart people.
Bored people.
And they weren't bored. They enjoyed this. This was their job. This is what they like to do.
Mrs. Ford,
Yes.
if the instructions don't say prove, what would they say where we could just like switch it?
No, this would be, remember those problems we were doing? That would show up as maybe a step somewhere.
Oh,
And so then you wouldn't have to go through all this, you could go straight from here to here within the proof. So the proof would not look like this. If it looks like this, that's what you're doing. But this might come up in the middle of a problem.
so if it's in the middle, then we can just switch it, but if it says prove, then we're doing everything.
Okay. Huh? Okay, go ahead.
I'm trying to see, like, would you use this, like, if you were making, like, a circular house or something? Is that how you would use it?
I have absolutely no idea, but you can research that and see. I need you back in your little seats at 12:20. All right? I will lock this room up when I leave. I do have to go to the bathroom. I'm gonna get some hot chocolate, so I will be out for a little bit, and I'll be back. You may stay in here, and if somebody's in here, the room's open.
10 minutes?